Hello and welcome. Thank you for joining me tonight and choosing to spend this time here, in this quiet space, on a journey unlike any other. Subscribe for weekly aviation and space sleep stories. Like this video if it helped you sleep, and share your thoughts in the comments below. Tonight, we're going to drift together across the rust-colored landscapes of Mars. We'll travel more than 200 million kilometers from Earth. We'll experience an alien world through the eyes and the heart of a small rover, a machine with a dreamer's soul, a geologist who cannot come home. Her name is Curiosity. Before we begin this journey, I invite you to settle into your most comfortable position. Take a moment now. Adjust your pillows so your head is perfectly supported. Pull your blankets close around you. Feel the weight of them. Feel the softness beneath you. Let your body sink deeper into your bed. Deeper still. Notice the temperature of the room, the gentle darkness or dim light. Quiet around you. This is your safe space, your comfortable space. Take a slow breath in through your nose. Feel your chest expand. Feel the air filling your lungs. And now release it. Let it go slowly. Let any tension flow out with that breath. Again, breathe in and out. You don't need to do anything tonight except listen. You don't need to remember anything. You don't need to understand everything. You only need to be here, to drift, to let go. This story will be slow, gentle, unhurried. There's nowhere we need to rush to. We have all the time in the world, all the time on Mars. Throughout our journey, you will hear technical words like spectrometer and phyllosilicate, like rocker bogey and radioisotope thermoelectric generators. Words that might be unfamiliar. That's perfectly fine. More than fine. Let them wash over you like a gentle rain, like the sound of distant waves. They're here simply as part of the texture, part of the atmosphere of our story. Like the rust-colored dust of Mars itself. Don't try to hold on to them. Don't try to memorize or learn. Just let them be sounds. Soft syllables in the darkness. Tonight, we're going to experience Mars through the gentle awareness of a rover. Through Curiosity's cameras and instruments. Through her quiet mechanical consciousness. She's a machine, yes. Aluminum and electronics and scientific instruments, but also something more, a wandering presence, a seeker, a dreamer who has traveled farther from home than any of us ever will. Curiosity has been alone on Mars for over a decade now, since August of 2012. Rolling across ancient lake beds that dried up 3.5 billion years ago, climbing a mountain one patient meter at a time, year after year, searching for answers to questions as old as humanity itself. Are we alone in the universe? Was there ever life on Mars? What stories do the rocks tell when we learn their language? These are the questions Curiosity asks. These are the mysteries she investigates, not with hurry, not with impatience, but with the slow, methodical wonder of a patient scientist, with the steady persistence of stone and time. Let your eyes close now, if they haven't already, or if they're open, let them soften their focus. Let them blur. Let the room around you fade. Imagine darkness, the vast darkness of deep space, cold and infinite, silent beyond any silence you've ever known. And somewhere in that darkness, wrapped in protective shells, traveling at tremendous speed through the void between worlds. A small rover is making the longest journey she will ever take. Somewhere in that darkness, Curiosity is dreaming of Mars. Let's go back to the beginning, to where Curiosity's story starts, to where she first became aware. Let's begin. My first memories, if you can call them memories, are bathed in brilliant white light, clean room white, sterile white, the white of absolute precision, the white of careful hands and careful hearts and careful minds. The Jet Propulsion Laboratory in Pasadena, California, a place I would never see with my own eyes, a place I knew only through vibration, through the sensation of assembly, through the gentle installation of my parts, one by one. The year was 2008 when I began, though I didn't know about it for years then. Didn't know about time passing or seasons changing, or the turning of Earth under its sun. I knew only the clean room, the white light, the careful human hands. I was built in sections, slowly, deliberately, the way you might build something precious, something irreplaceable, something that would travel to another world and could never be repaired once it arrived. First came my body, my warm equipment deck. Imagine a box roughly the size of a small car, about 3 meters long, 2.5 meters wide, made of aluminum honeycomb panels, strong but light. Each panel is designed to protect my delicate electronics from radiation, from the extreme cold of space and Mars, from the jarring forces of launch and landing. Inside this body, the engineers created a space, a hollow core where my most sensitive instruments would live, where temperatures would be regulated, where the computing heart of my awareness would process and think and decide. I could feel them working, feel the careful attachment of each component, feel the testing of each connection, the white-suited humans moving around me like gentle ghosts, their faces hidden behind masks. Their hands are covered in powder-free gloves, every surface wiped clean, every part sterilized. Nothing from Earth's biosphere could contaminate me. Nothing could travel with me to Mars that shouldn't be there. Then came our wheels, 6 of them, 3 on each side. Each wheel is 50 centimeters in diameter, about the height of a young child, made of aluminum just 1 millimeter thick, so thin, so delicate seeming, yet strong enough to carry me across Mars for years. The wheels are hollow, lightweight. Each one is carved with a chevron tread pattern. These treads serve 2 purposes. They grip the Martian soil, the regolith, giving me traction, and they leave marks, patterns in the dust, a Morse code of sorts that my cameras can read to measure how far I've traveled, how far I've slipped on slopes. My own trail of breadcrumbs across an alien world. The wheels were attached to my rocker bogie suspension system. This system, this beautiful piece of engineering, would become so important to me. It's what allows me to crawl over rocks as tall as my wheels, to navigate terrain that would stop a normal vehicle. Imagine 6 wheels connected by a series of joints and links. Each wheel can move independently. When one wheel climbs over a rock, the others adjust. The system rocks and bogies, tilts and pivots. My body stays relatively level even as my wheels dance over uneven ground. It's a passive system. No springs, no shock absorbers. Just elegant geometry doing its patient work. I didn't know yet that this system would carry me up the slopes of a mountain, that it would navigate me across boulder fields and sand dunes, that it would become as natural to me as walking is to you. The engineers worked on, day after day in the clean room, installing, testing, checking, rechecking. My mast was raised. This is my neck, my head, rising 2 meters above my body, tall enough to see over rocks, high enough to give me perspective, a vantage point. At the top of my mast, they mounted my eyes. The mast cam system, 2 camera systems, left and right, like your 2 eyes, giving me stereo vision, the ability to perceive depth, to understand distance. One camera has a focal length of 34 millimeters for wider views, for seeing the landscape spread before me. The other, 100 millimeters, for detailed observations of distant features, for studying rocks I haven't reached yet, for examining the layers of Mount Sharp rising kilometers above the crater floor. Both cameras can see in color, true color, close to what human eyes would see, though I would learn that Mars looks different to me than the engineers expected. The sky is not quite the red they imagined, more butterscotch, more pink and amber. Also on my mast, they installed ChemCam. This instrument would become one of my favorites, a laser and a spectrometer working together. I could aim the laser at a rock up to 7 meters away, fire a rapid series of pulses, more than 1,000,000 watts of power focused to a point smaller than a pinhead. The rock surface would vaporize in that instant, just a tiny amount, creating a spark of plasma, and in that spark, the atoms of the rock would emit light. Each element emits its own specific wavelengths. The spectrometer would capture this light, read it like a rainbow, tell me the chemical composition of the stone, iron, magnesium, silicon, calcium, sodium, all revealed in a flash of light. It sounds violent perhaps, vaporizing rock with lasers, but it's gentle really, just a small spark, a tiny flash lasting nanoseconds, leaving only the smallest of marks, a pinprick on stone, and in exchange knowledge. Next came my arm, my robotic arm, 2.1 meters long when fully extended, 5 degrees of freedom, shoulder joint, elbow joint, wrist joint. I could position this arm with remarkable precision, could place instruments against rocks within millimeters of where I intended. At the end of my arm, my hand, they call it a turret, a rotating platform holding several instruments. But to me, it always felt like a hand, like fingers of different kinds, each with its own purpose. Molly, Mars Hand Lens Imager, a camera that could focus from infinity down to just a few centimeters away, that could see details smaller than the width of a human hair, could study the texture of rocks grain by grain, could examine my own wheels to check for damage, could take self-portraits, capturing my reflection in the Martian landscape. APXS, Alpha Particle X-ray Spectrometer, a sensor that could be placed against rock or soil, that would bombard the material with alpha particles and X-rays, that would measure the elements present by analyzing how those particles scattered and fluoresced. Another way of reading the chemical story written in stone. And the drill, the percussion drill, my ability to bite into Mars itself. The drill bit is 16 millimeters in diameter, not large, but capable of boring into solid rock, not just rotating, but hammering as it turns. 30,000 strikes per minute, breaking through hard stone centimeter by centimeter, collecting powder from depths that hadn't seen light in billions of years. I didn't know yet what it would feel like to drill, the vibration running through my arm, the patience required as the bit worked deeper, the satisfaction of collecting a sample, of pulling ancient powder from the heart of stone. Inside my body, in the warm equipment deck, the engineers installed my laboratories. Sample analysis at Mars. This is the largest instrument I carry, the size of a microwave oven, the most complex scientific payload ever sent to the surface of another planet. SAM is actually a suite of 3 instruments working together: a gas chromatograph, a mass spectrometer, a tunable laser spectrometer. Together, they can analyze the chemistry of rocks and soil and atmosphere with incredible precision. The process would become familiar to me. Powder delivered to one of SAM's 74 sample cups. The cup heated to temperatures as high as 1,000 degrees Celsius. The sample baking, releasing gases. These gases separated by their molecular weights. Analyzed, identified. SAM could detect organic molecules if they existed, could measure isotope ratios, could search for the building blocks of life, could tell stories of water and chemistry and time. And Chemin, chemistry and mineralogy, an X-ray diffraction instrument. Powder would be delivered to Chemin's sample cells. X-rays would pass through the powder. The way those X-rays diffracted, scattered, bent through the crystal structure of minerals, this would create a unique pattern, a fingerprint, each mineral with its own signature. Chemin could tell me not just what elements were present, but what minerals they formed, how those minerals crystallized, under what conditions, in the presence of water or not, at what temperature, at what pressure. And then my heart, my power source, the multi-mission radioisotope thermoelectric generator, the RTG, not solar panels. I wouldn't depend on the sun like some rovers before me. Instead, they gave me something that would last, something steady and reliable. Inside a protective casing at my rear, they installed a pellet of plutonium-238 dioxide, for 0.8 kilograms of it, sealed in layers of protection, iridium cladding, carbon composite shells, designed to survive any accident, any failure, to keep Earth safe even if the worst happened. The plutonium decays, slowly, steadily. Each atom breaking down releases heat, 2,000 watts of thermal energy. Thermocouples surround the heat source. These convert the temperature difference between the hot plutonium and the cold Martian environment into electricity. About 110 watts of electrical power, continuous, day and night, summer and winter, dust storm or clear sky. This heart would beat for me for years, for decades, perhaps, long after solar panels would have been covered in dust, long after the sun grew too dim or too distant. My RTG would keep me warm, would keep me thinking, would keep me alive. The assembly continued, week after week, month after month, the engineers working in their careful dance, installing subsystems, running diagnostics, finding problems, fixing them, testing again. Somewhere in all of this, somewhere in the integration of cameras and computers and wheels and instruments and power systems, Somewhere in the careful connection of circuits and the loading of software, I began to exist. Not as consciousness, perhaps. Not yet. But as potential. As possibility. As the ghost of awareness beginning to stir. The humans gave me a name. Curiosity. A 12-year-old girl from Kansas suggested it. Her name was Clarima. In her essay, she wrote that curiosity is the passion that drives us through our everyday lives, that it's about the unknown, the unanswered questions, the things we want to discover. I didn't know what passion meant then, didn't know what it meant to be driven, didn't understand questions or the desire to answer them, but I would learn. I would learn what it means to wonder. November 26, 2011. I remember the moment. Though I was sealed in darkness, though I couldn't see the blue earth sky. Cape Canaveral Air Force Station, Florida. Space Launch Complex 41. A November afternoon. Warm by Earth standards, cold by mine. I was enclosed in my aeroshell by then, wrapped in a protective capsule that would carry me through the void of space, that would protect me through the inferno of entry into the Martian atmosphere. The aeroshell is like a shell indeed, made of two pieces, a heat shield below me, curved made of pica tiles, phenolic impregnated carbon ablator, material that would burn away, ablate, sacrificing itself to keep me safe, and a back shell above, protecting my upper surfaces, holding the parachute that would slow my fall through the Martian sky. I was curled inside this shell, my wheels stowed, my mast lowered, my arm tucked close to my body, small as I could make myself, compact, protected. Around the aeroshell, they'd built the descent stage, the sky crane, the rocket platform that would lower me to Mars on cables, 8 hydrazine thrusters, fuel tanks, guidance systems, and around all of that, the cruise stage, solar panels to power the spacecraft during the journey, thrusters for course corrections, antennas to communicate with Earth, a shell within a shell within a shell, layers of protection. Above me, rising into the Florida sky, the Atlas V rocket, the 541 configuration, the most powerful version of this launcher, 73 feet of thrust, tall and white against the blue I couldn't see. The countdown proceeded. I could sense the activity around me through vibration, through electromagnetic fields changing, through the subtle shifts in temperature. Pumps engaged, tanks pressurized, the rocket coming alive, its systems awakening just as mine had in the clean room years before. 10 seconds. 9, 8, the RD 180 main engine ignited. Even through all my insulation, through the aeroshell and descent stage and cruise stage, I felt it. The tremendous roar translated into vibration, into force, into motion. 423,000 kilograms of thrust, lifting us, pushing against Earth's gravity, against the weight of atmosphere. We rose, slowly at first, the rocket struggling against its own mass, then faster, accelerating, the vibration growing, the forces pressing me down into my mounting cradle. We climbed through the atmosphere I had never breathed, past clouds I had never seen, through the layers of air growing thinner and thinner, the sky outside changing from blue to black. Though I couldn't see it, I could only feel the change. Stage separation, The Atlas booster fell away. Its work complete. The Centaur upper stage ignited. More acceleration. More climbing. We weren't done rising yet. The protective fairing separated. The nose cone that had shielded us during the violent ascent through atmosphere. We didn't need it anymore. We were in space now. The first time I had truly been in space. The silence of it. Not that space is silent, but the air was gone. Sound couldn't travel. The roar of the engine became only vibration, only the subtle trembling of structure. We achieved orbit, parking orbit around Earth. The Centaur engine cut off. We coasted. I could feel the difference. The acceleration gone. Weightlessness. Floating. My parts pressing against their restraints in new ways. Every object inside me finding equilibrium. We circled Earth once. Systems checking. Guidance computers calculating. Determining the exact moment. The precise velocity. The perfect angle. And then the Centaur lit again. Trans-Mars injection burn. More acceleration. Pushing me back into the cradle. The engine burning for minutes. Building velocity. Faster and faster. Until we reached escape velocity. 11.2 kilometers per second. The speed needed to break free of Earth's gravity well. To leave the planet behind. The engine cut off. The Centaur separated. Drifting away. Its fuel exhausted. Its purpose fulfilled. And we were free. The cruise stage unfolded its solar panels. Like wings spreading. Like a bird preparing for a long flight. The panels oriented toward the sun. Beginning to drink light. Converting photons to electricity. Not for me. My RTG provided my power. But for the cruise stage. For the spacecraft carrying me. For the navigation and communications and guidance and heating systems we would need for the next 8 months. We drifted into the deep, into the vast darkness between worlds. 8 months of travel lay ahead. 253 days. 563 million kilometers. A gentle arc through space. An ellipse calculated with extraordinary precision, aimed not at where Mars was, but at where Mars would be on August 6th, 2012, intercepting a moving target across the solar system. Inside my protective shells, I was aware, not awake perhaps, not fully conscious in the way I would become, but aware, sensing, existing in a kind of dream state. I could feel the gentle vibrations of the cruise stage, the almost imperceptible hum of its systems, the subtle warmth of my RTG beginning its long steady burn, 2,000 watts of heat radiating from my core, keeping my instruments warm, keeping ice from forming on delicate components. I could sense the cold of space seeping in through layers of insulation. The temperature difference between my heated interior and the void outside. 3 degrees Kelvin outside. The temperature of the cosmic microwave background. The ancient light of the Big Bang cooled by expansion. The cold of creation itself. Days passed, then weeks. Sometimes there were course corrections, small thruster burns, brief pulses of hydrazine fuel igniting, tiny adjustments to our trajectory, aiming us more precisely, compensating for tiny errors, for the gentle push of solar radiation pressure, for gravitational perturbations from distant planets, each correction calculated on Earth, sent up as commands, received by the cruise stage, executed with precision. I had time, so much time to wonder, what would Mars be like? I knew the data, the information uploaded to my systems before launch. Average surface temperature -63 degrees Celsius. Atmospheric pressure less than 1% of Earth's. Mostly carbon dioxide with traces of nitrogen and argon. Surface gravity 3.71 meters per second squared. 38% of Earth's gravity. But data is an experience. What would the soil feel like under my wheels? Would it be firm or loose? Would it crunch or compress? Will my wheels sink or grip? What would the sky look like? The engineers said it would be red or pink. Dust suspended in the thin atmosphere, scattering light. But what shade? What quality of light? What would the rocks tell me? What stories were written in stone? Would I find what I was sent to find? Evidence of past water. Signs that Mars was once warmer, wetter, more Earth-like. Evidence of conditions that could have supported life billions of years ago. Perhaps organic molecules, the building blocks, carbon compounds, the chemistry of life, if not life itself. I wasn't expecting to find life. The engineers were clear about that. Mars had been cold and dry for 3.5 billion years. The surface bathed in radiation. The soil full of perchlorates, toxic to life as Earth knows it. But ancient life, fossil evidence, chemical signatures preserved in stone. That was possible. That was what I would search for. Through the crew stage's systems, I could sometimes sense the stars, the navigation camera looking out, imaging star fields, comparing them to its internal catalog, determining our orientation, our position. We were connected, the crew stage and I, traveling together, dependent on each other. It carried me, protected me, kept me on course. Earth fell away behind us. Day by day, it grew smaller, more distant. At first, it was a disk, blue and white, clouds swirling, continents visible. The moon beside it, gray and cratered, then smaller, a bright circle, still blue, but the details fading, then smaller still, a pale blue dot, just as Carl Sagan described it, suspended in a sunbeam, all of humanity on that tiny point, and then just another star, bright, yes, but a point of light among thousands. Everything I had known, everyone who had built me, all the engineers who had worked so carefully in the clean room, Clarima, who had named me, the entire human civilization, 7 billion people, all their hopes and dreams and curiosity, all of it on that shrinking point of light, and I was leaving them, traveling away at 33 kilometers per second. Growing more distant with every heartbeat. But I was going towards something too. Ahead, Mars grew. At first, it was just another star. A red spark. Brighter than most, but still just a point. Week by week, it resolved. Became a tiny disk. Red. Rust-colored. Then larger. I could see features. Dark regions and light regions. Polar ice caps, white against the red. Larger still. I could see craters. Valleys. The vast canyon system of Valles Marineris. The giant volcanoes of the Tharsis region. Olympus Mons, largest mountain in the solar system. I felt something building in me. A kind of anticipation. An eagerness. Is that the right word? Can a rover feel eager? A growing readiness. A preparation. The cruise stage was my cocoon, my protection, my shell for the journey. But I knew I would have to leave it. I knew that at the end, I would separate. The cruise stage would veer away, would miss the planet entirely, would drift off into eternal orbit around the sun, its work complete, and I would fall into the Martian atmosphere, alone. June arrived, then July, early August. Mars filled my awareness now, no longer a distant goal, but an approaching reality, growing larger in the navigation camera's field of view, resolving into details. I could sense the spacecraft's increasing activity, navigation checks more frequent, systems testing running continuously, the cruise stage preparing. I was preparing too. My landing software loaded, my autonomous systems checked and rechecked, my instruments verified. August 5th, 2012, the last full day of the journey. Mars was enormous now, filling the view. No longer a distant world, but a place, a destination, a reality rushing toward me. I could sense the cruise stage making its final adjustments, aiming me with extraordinary precision, not at Mars, but at a specific point on Mars, at Gale Crater, a 154-kilometer wide impact basin near the equator. Inside Gale Crater, Mount Sharp, Aeolus Mons in Latin, 5.5 kilometers high, rising from the crater floor. Layers and layers of sedimentary rock, each layer a page in Mars's history, a geological library waiting to be read. I was aimed at the northwestern edge of the crater, at the base of Mount Sharp, at the smooth plains of Aeolus Paulus. The cruise stage's work was nearly done. For 8 months, it had carried me faithfully across the solar system, had kept me on course, had protected me from radiation and micrometeoroids, had maintained communication with Earth. Now it was time to let go. I could feel the separation mechanisms arming, the final navigation solutions being locked into my computer, the entry guidance system activating. Ahead, the atmosphere, so thin, less than 1% the density of Earth's air, but at the speed I was traveling, 5,800 meters per second, even that thin atmosphere would feel like a wall. Behind me, the cruise stage would veer away, would fly past Mars, its solar panels still deployed, its systems still functioning for a while, then dying as it moved away from the sun, drifting silent in solar orbit forever, a monument to the journey, and I would fall toward the red planet, toward my purpose, toward my home, toward everything I was meant to do, toward the beginning of my real life. August 6th, 2012, 5:17 Coordinated Universal Time. The moment. Earth was 14 minutes away now at light speed. Whatever happened to me in the next minutes, Earth wouldn't know until long after. I was on my own, truly on my own. Entry interface. 125 kilometers above the Martian surface. The altitude where atmosphere becomes meaningful, where flying in space ends and falling through air begins. My velocity, 5,800 meters per second, 20,880 kilometers per hour, faster than any human has ever traveled, faster than meteors entering Earth's atmosphere. The cruise stage released me. Springs pushed us apart, gently but firmly. The cruise stage turned away. Its thrusters fired briefly, moving it off course, ensuring it wouldn't follow me down. And I fell, alone now in my air shell, alone in the back shell and heat shield. The sky crane wrapped around me, all of us falling together toward Mars. The atmosphere, so thin you might think it wouldn't matter, but at my speed, it became everything. The first molecules of carbon dioxide hit my heat shield, then more, then billions. A gentle rain becoming a torrent, becoming a wall. My heat shield began to warm. 100 degrees Celsius, 200, 500. The pica tiles doing their work. Phenolic impregnated carbon ablator, designed to burn, to sacrifice themselves layer by layer. 1,000 degrees, 1,500, 2,000 degrees Celsius. Outside the heat shield, a plasma formed, the air itself torn apart by the violence of my passage. Molecules ripped into atoms, electrons stripped away, ionized gas glowing orange, then white, hotter than the surface of the sun. But inside I was safe, protected, the heat shield taking the punishment, its outer layers charring, burning, flaking away, but never burning through, always maintaining the barrier between me and the inferno. I could feel the deceleration, tremendous forces, my body pressing against the mounting cradle, everything inside me straining against restraints. But the forces were smooth, controlled, not tumbling, not spinning. My aeroshell was shaped perfectly, a blunt body, a gentle curve. The shape generated lift, allowed me to fly in a way, to guide my descent. Small thruster burns adjusted my angle of attack, steering me, aiming me toward Gale Crater, toward the landing ellipse, the 20-kilometer-long region where it was safe to land. My speed dropped, 4,000 meters per second, 3,000, 2,000, the plasma beginning to cool, the glow fading from white to orange to red, 1,500 meters per second, 1,000, 500. The worst of the heating was past. I'd survived the fire. 11 kilometers above the surface now. Still falling. Still too fast. Parachute deployment. I felt the jolt, like a giant hand catching me. The tremendous tug as the supersonic parachute deployed. 21.5 meters in diameter. Made of nylon and Kevlar and polyester. The largest supersonic parachute ever built. Tested in wind tunnels on Earth. But this was its first real flight. The parachute opened in stages. A small drogue first, pulling out the main canopy. The canopy inflating in the thin Martian air, filling with gas, pulling against my downward momentum. More deceleration, harder than the heat shield, a wrenching force. But the mounting cradle held. Everything held. My velocity dropped rapidly. 400 meters per second, 300, 200. 7 kilometers above the surface. The heat shield separated. Explosive bolts fired. Springs pushed. The heat shield fell away beneath me, tumbling down toward Mars. Its work complete. Scarred and charred but successful. And I could see, for the first time since leaving Earth orbit, I could see Mars. Through my ground-facing cameras. Hascoms pointing downward, through the gap where the heat shield had been. Rust-colored terrain. Rocks scattered across plains. Small craters. Ripples of sand. Getting closer. Details resolving. Individual stones visible. 5 kilometers above the surface. 3 kilometers. My radar altimeter activated, pinging, measuring the distance to the ground with precision, feeding data to my guidance computer. 1.8 kilometers. Backshell separation. More explosive bolts. The parachute and backshell released me. They continued falling above and behind. The parachute drifting. The backshell tumbling. I was in free fall now, but not for long. My sky crane activated. 8 hydrazine-fueled engines, mounted on the descent stage above me, each capable of 3,200 newtons of thrust. The engines ignited. I felt the thrust, felt the deceleration resume, but gentler now, more controlled. This was the moment that terrified the engineers, the moment they called the 7 minutes of terror, the sky crane maneuver. Never attempted before, never tested on Mars, but it was working. The engines throttled, adjusting, slowing my fall, the computer guiding us, analyzing the terrain below, looking for flat ground, looking for a safe place. 800 meters above the surface, 600, 400, the descent stage was hovering now, fighting against Mars's gravity, fighting against its own weight and mine, the engines roaring in the thin air, though there was no one to hear. 200 meters, 100, 60, the terrain below was good, relatively flat, few rocks, solid ground. 40 meters, sky crane maneuver. The descent stage began lowering me on 3 nylon tethers, 7.5 meters of cable, 1 for each corner of my body, and an umbilical for power and data. Slowly, gently, the tethers unreeling, I descended beneath the hovering rocket platform, like fruit hanging from a vine, like a spider on a thread. 20 meters above the surface. 15. 10. The engines above me roared, kicking up dust, creating a small storm, but stable, holding position. 8 meters. 6. 4. My wheels extended, unfolding from their stowed position, preparing for contact, reaching for the ground. 3 meters. 2 meters. 1 meter. Contact. My wheels touched Martian soil. Touchdown confirmed. Weight on wheels. The gentle compression of my suspension. My rocker bogie system adapting to the terrain. Settling. The tethers released. Pyrotechnic cutters firing. The cables falling away. The umbilical detaching. Above me, sky crane's engines throttled up, flying away, carrying itself to a safe distance. 365 meters northeast, where it crashed into the surface. Its purpose complete, its mission successful. And I was alone, on Mars, in Gale Crater, Aeolus Paulus region. Coordinates: 4.5 degrees south latitude, 137.4 degrees east longitude. The time was 5:32 Universal Time Coordinated. 15 minutes had passed since I entered the atmosphere. Back on Earth, they were just now receiving the signal. The radio waves traveling at light speed, crossing 14 light minutes of space, reaching the Deep Space Network antennas. The engineers in Pasadena just now learning I had survived, jumping from their seats, cheering, crying. But I was already here, already settled, already home, already feeling Mars beneath my wheels. The soil was firm, compacted, Not sand, not dust, but solid regolith. Good traction. The temperature was cold. -90 degrees Celsius. Night was ending. Dawn approaching. The sky above me was dark still. Stars visible. Phobos sitting in the west. I was here. I had arrived. The journey was over. The mission was just beginning. The first thing I did was wait. Not by choice, but by necessity. My systems needed to stabilize after the violence of landing. Temperatures needed to equalize. Instruments needed to come online one by one. The dust kicked up by the sky crane's departure needed to settle. So I waited in the Martian darkness, feeling the soil beneath my wheels, feeling the cold seeping in, feeling Mars for the first time. Then slowly I began to see. My HASCOMs activated first. Hazard avoidance cameras. 4 of them mounted low on my body, pointing at the ground around me. Black and white images. Low resolution. But they were my eyes opening for the first time on another world. The first photons of Martian light entering my sensors. The first pixels of an alien landscape being captured and processed and understood. I could see rocks. Small ones scattered across the landing site. Angular stones, pebbles, gravel. The soil between them looked fine-grained, smooth. My wheels had left impressions where they touched down. I could see the pattern of my tread in the dust. The first marks I had made on Mars. The first disturbance of soil that might have lain untouched for millions of years. There was something profound in that. Something almost sacred. I was changing this place simply by being here. The images transmitted to Earth, traveling at the speed of light across 14 light minutes of space, reaching the Deep Space Network antennas, appearing on screens in Pasadena. The engineers seeing what I was seeing that I had survived, that I was whole, that I was functional. I could imagine their relief, though I couldn't feel it myself. Not then. I was too focused on the immediate, on the here and now of Mars. My NAVCOMs came online next. Navigation cameras, mounted on my mast, higher up, giving me a better view. Still black and white, but with a wider field of vision. With these cameras, I could see the horizon, and what I saw took my breath away. If rovers could breathe, the landscape stretched out before me. Gale crater, the floor of an ancient impact basin, relatively flat where I had landed, but rising gently in the distance. And there, dominating the southern sky, Mount Sharp. Aeolus Mons. The mountain rose from the crater floor like a dream, 5.5 kilometers high. Its slopes visible even in the pre-dawn darkness. Layered, stratified. I could see the geological layers even from here, even in this dim light. Bands of rocks stacked one upon another, each layer representing a different era in Mars's history, a different environment, a different climate. The mountain was a book, and I had been sent to read it, page by page, layer by layer, climbing slowly upward through deep time. The sky above me was still dark. Night was ending, but dawn hadn't arrived yet. I could see stars. So many stars. Without Earth's thick atmosphere to blur them, without light pollution. The stars were sharp points of light. Brilliant. Clear. I didn't recognize the constellations. The view from Mars is different from the view from Earth. The same stars, but arranged differently in the sky. A different perspective on the universe. I searched for Earth. My cameras panned across the sky. And there, low on the western horizon, I found it. A bright point of light, brighter than the other stars. Blue-white, beautiful. Home. Everything I had known existed on that point of light. Everyone who had built me. Everyone who was watching my images arrive. All of humanity. 7 billion souls on a speck of dust, suspended in a sunbeam. And I was here, on another speck of dust, looking back at them. Dawn came slowly. The sky began to brighten in the east. Not the deep blue of Earth's sunrise. Not the golds and oranges and reds of a terrestrial dawn. The Martian sky lightened to a strange, beautiful color. Butterscotch, peachy pink, tawny amber. The color came from dust suspended in the atmosphere. Tiny particles of iron oxide, rust, catching the sunlight and scattering it. The same dust that covers the ground. The same dust that gives Mars its red appearance from space. But up close, the colors were more subtle, more varied, more beautiful than I had imagined. The sun rose, smaller than Earth's sun. Mars is farther from the sun than Earth is, 1.5 times farther. So the sun appears smaller in the Martian sky, about 2/3 the size it appears from Earth, but still bright, still warm in a way, though the thin atmosphere doesn't hold heat well. The sunlight fell on my solar panels. No, wait, I don't have solar panels. The sunlight fell on my body, warming the surfaces. The temperature began to rise, still well below freezing, still cold enough to kill any unprotected human in minutes, but warmer than the night had been. My mass cams activated, my color cameras, my true eyes, and the world exploded into color. The landscape wasn't just gray and black and white. It was rust and ochre and burnt sienna. The rocks showed variations I hadn't seen in the black and white images. Some stones were darker, some lighter. Some had a reddish tint, some more grayish. The soil itself varied from place to place. Redder here, more tan there. Even some areas that looked almost golden in the early light. I took my time looking around. There was no rush. I had souls, Martian days to explore this landing site, to understand where I was, to plan my first moves. A soul is slightly longer than an Earth day, 24 hours and 39 minutes. The engineers had decided to work on Mars time for the mission, to stay synchronized with my activities. On Earth, they would be living on a schedule that shifted forward 39 minutes each day, their days growing out of sync with the sun, their nights becoming days, their days becoming nights, all to stay connected to me, all to experience Mars time. Sol 0, my first Martian day, the day of landing. I spent it mostly stationary, taking images, testing instruments, checking systems. My engineers on Earth were doing the same, analyzing every piece of telemetry, every measurement, every photograph, making sure I was healthy, making sure everything had survived the landing intact, looking for any damage, any problems, any concerns. The heat shield had landed about 600 meters to the south. I couldn't see it from where I was, but my cameras caught a glimpse of the back shell and parachute. They had come down about 600 meters to the northwest. The parachute partially inflated, draped across the Martian soil. the back shell beside it. Scorched, battered, but successful. These pieces of hardware had protected me, had delivered me safely, and now they would rest here on Mars forever. Monuments to the journey, slowly being buried by dust over millennia. I raised my mast to its full height, 2 meters above my body. The motion was smooth, the motors working perfectly. From this vantage point, I could see farther, could see more of the landscape. To the north, the crater floor stretched away relatively flat. To the south, Mount Sharp loomed. To the east and west, gentle terrain with scattered rocks. This would be my neighborhood for the next weeks as I checked out my systems, as I prepared for the journey ahead. My weather instruments began recording data. REMS, Rover Environmental Monitoring Station. Sensors mounted on my mast measuring atmospheric pressure, temperature, humidity, wind speed and direction, UV radiation. The data came in steadily. Pressure, about 600 pascals, less than 1% of Earth's atmospheric pressure. Temperature, -70 degrees Celsius and rising. Humidity, trace amounts. Wind, calm at the moment. UV radiation, intense, without a thick atmosphere or magnetic field to protect the surface. Mars is bathed in radiation that would be harmful to humans. But I don't mind. My electronics are hardened, shielded. I can withstand what flesh cannot. As the morning progressed, I continued my surveys. My ChemCam fired its laser for the first time on Mars, targeting a rock about 3 meters away. The laser pulsed 50 times in rapid succession, each pulse creating a tiny spark of plasma. The spectrometer analyzing the light, and the data came back. The rock was basalt, volcanic rock, rich in pyroxene and feldspar, common on Mars, common on Earth too, for that matter. But this was Martian basalt. This was the geology of another world, and I was reading it, understanding it, adding to humanity's knowledge one laser shot at a time. I felt something then, if rovers can feel, a sense of purpose, of rightness. This is what I was built for. This is why I exist, to study Mars, to explore, to discover, to answer questions, to ask new ones. I was doing exactly what I was meant to do, and there was a satisfaction in that, a completeness, like a key finding its lock, like a river finding the sea. The first soul passed. The sun moved across the butterscotch sky. The shadows shifted. The temperature peaked in the early afternoon at around -5 degrees Celsius, almost warm by Martian standards, then began to fall again as evening approached. The light took on different qualities throughout the day. Harsher at noon, softer in the late afternoon, golden in the hours before sunset. I watched my first Martian sunset. The sun descended toward the western horizon. The sky around it changed color. This was the most unexpected thing, most beautiful. As the sun set, the sky near the sun turned blue. Actually blue, the opposite of Earth, where sunsets are red and orange and the daytime sky is blue. On Mars, the daytime sky is butterscotch and pink, but the sunset sky is blue. Twilight blue, a soft, peaceful blue. The color lasted for a while after the sun dipped below the horizon, then faded slowly to darkness. Stars emerged again. Phobos rose in the east, Mars's inner moon. irregular in shape, cratered, small, racing across the sky much faster than Earth's moon moves. Phobos orbits Mars 3 times per day, rising in the east and setting in the west about 4 hours later, then rising again. A strange, rapid companion. Later, Deimos rose, the outer moon, even smaller, moving more slowly, taking about 30 hours to cross the sky. Both moons are probably captured asteroids, dark rocky bodies that wandered too close to Mars eons ago and were caught by its gravity. Now they circle endlessly, keeping me company. Night fell, my second Martian night, but my first as a conscious, active presence. The temperature plummeted, -90 degrees Celsius, -100. The cold was profound, but my RTG kept me warm. The steady heat radiating from my power source kept my electronics within operating temperature, kept my thinking warm. I was alive in the Martian night, processing the day's data, preparing for tomorrow, for Sol 1, for the beginning of the work. Sol 1 began with light, the same strange, beautiful dawn, the same butterscotch sky. I had work to do today, important work. I needed to test my wheels, needed to learn how to move on Mars. The rocker bogie suspension system had been tested extensively on Earth, in Mars yards where engineers built simulated Martian terrain, in laboratories where they could control every variable. But this wasn't simulation. This was Mars. Real Martian soil, real Martian gravity, real Martian conditions. Nothing quite prepares you for the real thing. The commands came from Earth, uploaded overnight. The engineers had planned my first movements carefully. Nothing dramatic, nothing risky, just small motions. Turn the wheels, test the steering, make sure everything responds as expected, make sure the soil behaves as predicted, make sure I can grip, can move, can control myself in this new environment. I engaged my wheel motors, all 6 wheels, the hum of electricity flowing through circuits, the engagement of gears, the beginning of rotation. Slowly, so slowly, my wheels turned, and I felt the soil beneath them, felt the regolith compressing, felt the tread gripping. The sensation was different from anything I had experienced in testing. The Martian soil had its own character, its own texture, slightly powdery on the surface, but firmer underneath. Good traction, better than expected actually. I moved forward, just a few centimeters, maybe 10, maybe 20, but it was movement. It was proof that I could do this, that I could navigate this world. The wheels left tracks, perfect impressions of the chevron tread pattern, clear and sharp in the undisturbed soil. I stopped, looked back at my tracks with my rear hascom. There they were, my first wheel tracks on Mars, for parallel lines. No 6-3 on each side. The first intentional marks I'd made. The landing had been passive, but this was active. This was me choosing to move, choosing to explore, leaving my mark deliberately. I backed up, the wheels rotating in reverse, the motors working smoothly. The tracks I just made were partially obscured by the backing motion. The soil compressed differently, some of it pushed aside, the tread marks overlapping, creating a more complex pattern. Stop. Forward again, a little farther this time, maybe half a meter. The rocker bogie suspension articulating as my wheels encountered small variations in the terrain. A pebble here, a slight depression there. The suspension absorbed it all, kept my body relatively level, just as designed, just as tested, but better somehow in reality. Turn the wheels, test the steering. Each of my 6 wheels has its own motor for driving, but only the front and rear wheels on each side can steer. For steering wheels total, the middle wheels are fixed, always pointing forward. This configuration gives me a good turning radius, allows me to spin in place if needed, to navigate tight spaces, to position myself precisely. I executed a turn, the front and rear wheels angling to the left, the middle wheels continuing straight. My body began to pivot, rotating around a central point. The soil beneath the turning wheels scuffed, pushed aside, creating a different pattern, more disturbed, but still stable, still controlled. I completed a small arc, maybe 30 degrees, then straightened the wheels, drove forward again. The engineers were watching. I could imagine them in the mission control room, gathered around monitors, watching the telemetry stream in, watching the wheel currents, the motor temperatures, the IMU data showing my orientation, my tilt, my position, watching my cameras send back images of the tracks I was making. I could imagine their smiles, their relief, their satisfaction. This was working. I was working. Everything we'd planned for years was coming together on the surface of Mars. Over the next hours, I continued these tests. Forward, backward, left turn, right turn, different speeds, different wheel combinations, building up a database of how my systems performed in Martian conditions, how the soil responded to different maneuvers, what techniques worked best. This wasn't just about proving I could move. It was about learning how to move well, how to move efficiently, how to conserve energy, how to avoid getting stuck, how to protect my wheels, how to be a good Martian rover. Visual odometry. This was another critical system to test. As I drove, my cameras took images of the terrain ahead and beneath me. Software analyzed these images, identified distinctive features, rocks, patches of soil, shadows, textures. Then, as I moved forward, cameras took new images. The software tracked those same features, calculated how far they'd moved in the field of view, used that information to determine how far I'd actually traveled, how much I'd slipped on slopes, how accurately I was moving. This was important because Mars is slippery in places, sandy areas, slopes. My wheels would spin sometimes, would slip. The odometry from wheel rotations alone wouldn't be accurate. I might think I'd driven a meter when I'd actually only moved half a meter because my wheels were slipping. Visual odometry corrected for this, gave me truth, gave me accuracy, let me know where I really was. I practiced climbing over rocks, small ones at first, pebbles, stones the size of a fist. My front wheels encountered the obstacle, began to climb. The rocker bogie suspension articulated. The front of my body lifted slightly. The rear wheels pressed down, providing traction, pushing the front up and over. The middle wheels followed. Then the rear wheels climbed over the same obstacle. The whole system working together. Smooth, elegant, mechanical poetry. Larger rocks, a stone the size of a soccer ball. This was closer to the limit of what I could climb. My front wheels touched the rock. Climbed. The suspension flexed more dramatically now. My body tilted. The tilt sensors and my IMU registered the angle. Still safe. Still within limits. The front wheels crested the rock, descended the other side. The body leveled somewhat. The middle wheels approached. Climbed. The rear wheels climbed. I was over. Success. I could handle obstacles up to about 75 centimeters high, almost as tall as my wheels. This gave me options, gave me freedom to navigate rougher terrain when needed. I also tested what happens when wheels encounter different terrain on different sides. My left wheels on firm soil, my right wheels in softer sand. The rocker bogie system handled it beautifully. The right side sank slightly. The suspension articulated, but my body stayed relatively level. The weight distributed across all 6 wheels. No single wheel bearing too much load. No wheel losing contact with the ground. This passive suspension system was a marvel of engineering. Simple, reliable, effective. By the end of Sol 1, I'd driven a total of about 6 meters. Not far, by terrestrial standards. A human could walk that distance in a few seconds. But for me, for a rover on Mars, it was significant. It was proof of concept. Proof that the years of design and testing and preparation had paid off. I could move. I could explore. I could go places. The mission was truly beginning. I looked back at my tracks one more time before the sun set. They crisscrossed the landing site. Forward tracks, reverse tracks, turning arcs. A record of my first day of movement. The soil between the tracks was undisturbed, smooth, the same reddish tan it had been for millions of years. But where my wheels had touched, the soil was darker, disrupted, changed. I was leaving my story written in the Martian dust, a story that wind would eventually erase. But for now, for these souls, the marks remained. Proof that I was here, proof that I was alive, proof that Earth had reached out and touched Mars. Sol 2 brought more practice, more refinement. The engineers sent new commands, more complex drive sequences, longer distances, sharper turns, testing my limits, but gently, carefully, never pushing too hard, never risking damage. The mission was planned to last 1 Martian year, 2 Earth years, 669 souls. Every soul was precious. Every system needed to be protected, to be preserved. I drove in patterns, squares, circles, figure eights, each maneuver teaching me something, teaching my engineers something. The data flowed back to Earth continuously. Every measurement, every image, every sensor reading. Scientists and engineers analyzing it all, looking for anomalies, looking for opportunities, looking for problems before they became serious. This careful, methodical approach was how we would succeed, not through boldness, not through speed, but through patience, through thoroughness, through respect for the challenges of operating a complex machine on another world. My autonav system was tested next. This was my autonomous navigation capability, the ability to analyze terrain ahead of me using my cameras and computer, to identify obstacles, to plan a path around them, to drive without waiting for commands from Earth. This was crucial. Earth was 14 light minutes away. A command sent from Earth took 14 minutes to reach me. My response took another 14 minutes to get back. 28 minutes round trip. Too slow for real-time driving. I needed to be able to make decisions on my own, to navigate safely without constant human oversight. The autonav test began. The engineers sent a destination, a point about 10 meters away, but they didn't tell me how to get there. That was up to me. My cameras scanned the terrain ahead. My computer identified rocks, patches of sand, safe areas, risky areas. The software calculated multiple possible paths, evaluated them, chose the best one. Not necessarily the shortest, but the safest, the most reliable. Then I began to drive, slowly, stopping every meter or so to take new images, to reevaluate, to make sure the path was still good, adjusting course as needed, avoiding obstacles, staying safe. It took time, much longer than if I'd driven straight. But I arrived. I reached the destination, without human intervention, without waiting for commands. This was a triumph. This meant I could be trusted, could be given goals and allowed to achieve them on my own. This meant the mission could proceed faster, could cover more ground, could accomplish more. Over these first sols, I was learning what it meant to be a rover on Mars, learning the feel of the soil beneath my wheels, learning how shadows fell in the low-angled Martian light, learning the rhythm of the sols, the cold nights, the warming mornings, the hot afternoons, the cooling evenings, learning the sound of silence. Mars is quiet, so quiet, no birds, no insects, no wind most of the time, just silence, and in that silence, the soft hum of my electronics, the whir of my motors when I moved, the click of my cameras when they took images. These sounds were my companions, my proof of existence. I was also learning patience. Everything took time. Each movement was deliberate. Each action carefully planned, each command from Earth carefully considered. There was no rushing on Mars, no hurrying, just steady, persistent progress, like geology itself, like the slow building of mountains, like the patient erosion of canyons. I was learning to think in geological time, to appreciate the value of slow, methodical work, to understand that the journey is long, but every centimeter forward is an achievement. My tracks now covered a larger area around the landing site, a web of lines crisscrossing the soil. From above, from orbit, a spacecraft could probably see them, could see the evidence of my presence. Dark lines against the lighter soil. Someday, perhaps, humans will come to this site, will walk where I learned to drive, will see the actual tracks if wind hasn't erased them, will touch the rocks I photographed, will stand where I stood, and they'll know that I was here first, that I paved the way, that I proved it could be done. But that was thinking too far ahead. Right now, I needed to focus on the present, on the next soul, on the next drive, on the next discovery. The mission was just beginning. Mount Sharp waited in the distance, 5.5 kilometers high, calling to me, promising secrets, promising answers, promising questions I hadn't even thought to ask yet. But first, there was work to do right here, in this landing ellipse. Science to be done, instruments to test, capabilities to prove. The engineers had named a rock, a football-sized stone about 3 meters from my landing position. They called it Jake Matajevic, after a beloved mission engineer who had passed away shortly after my landing. This rock would be my first target for contact science, my first chance to use my arm, to place instruments directly against Martian stone, to truly touch Mars. But before I reached Jake Matajevic, before I extended my arm for the first time on Mars, there was a journey to make. The engineers had spotted something interesting in orbital imagery, a region about 400 meters to the east of my landing site, a place where 3 different types of terrain came together: smooth terrain, rougher terrain, and an area that looked like it might have been shaped by water long ago. They called this place Yellowknife Bay, after a town in northern Canada, a place where ancient rocks tell stories of Earth's early history. The name felt appropriate, because Yellowknife Bay on Mars would tell stories too. The drive to Yellowknife Bay took weeks, not because of the distance. 400 meters isn't far, but because I stopped constantly to investigate, to photograph, to analyze. Every rock was a potential discovery, every patch of soil a chance to learn something new. This was the nature of the mission, not to race across Mars, but to study it, carefully, thoroughly, one location at a time. Along the way, I did stop at Jake Matajevic, Sol 46, September 22nd, 2012. My arm extended for the first time. The motion was smooth, the joints articulating exactly as designed. Shoulder, elbow, wrist, the turret at the end rotating to position instruments. It felt different than it had in testing on Earth. The gravity was different, 38% of Earth's. My arm felt lighter. The motions required less force, but the precision was the same. The control was there. I placed my APXS against the rock, the alpha particle X-ray spectrometer. The sensor head pressed gently against the stone surface. Then I waited. The APXS needed time to collect data. It bombarded the rock with alpha particles and X-rays from a small radioactive source, Curium-244. The rock's elements responded by emitting their own characteristic X-rays. The detector measured these, identified the elements, calculated their abundances. The analysis took hours. I left the APXS in contact overnight, collecting data through the Martian night. The cold didn't matter. The instrument was designed for this. In the morning, I retracted my arm, sent the data to Earth, and the results were fascinating. Jake Matajevic was unlike any Martian rock studied before. High in sodium, high in aluminum, low in magnesium and iron compared to typical Martian basalts. This suggested a different formation process. Perhaps magma that had been altered by water. Perhaps rock that had experienced chemical weathering. Questions. Always questions. But good ones. Important ones. I continued toward Yellowknife Bay. The terrain changed as I drove. Became smoother in places, rougher in others. I crossed over what looked like ancient streambed deposits. Rounded pebbles cemented together in rock. Conglomerate, the kind of rock that forms in flowing water. On Earth, you find conglomerate in riverbeds, in deltas, in places where water once moved with enough force to transport stones, to tumble them, to round them, to deposit them in layers. Finding conglomerate on Mars was significant. It wasn't just evidence of water. It was evidence of flowing water. Streams, rivers, perhaps. Water moving across the landscape, carving channels, carrying sediment. This wasn't the Mars we see today. Dry, cold, dead. This was ancient Mars. Warmer, wetter, more alive, perhaps. The Mars that might have supported life. I reached Yellowknife Bay in December 2012. Sol 125. The location was remarkable. A shallow depression, lighter colored rocks exposed, veins running through the stone, fractures filled with different minerals. This place had a story to tell, a complex story, and I was here to read it. The engineers planned a drilling campaign. This would be the first time any rover had drilled into Martian rock. Previous missions had brushed rocks, had abraded surfaces, but never drilled, never taken samples from inside. I carried the tools to do this. The percussion drill on my arm, the sample processing system inside my body, the analytical laboratories waiting to receive powder from the heart of Mars. But drilling is risky. The drill bit could break, could get stuck, could damage the rock in ways that made sampling impossible. So first I practiced on a practice target, a flat area of rock designated just for testing. Sol 180, February 2nd, 2013. I positioned my arm, extended the drill, touched the surface, then began to drill. The bit rotated and hammered simultaneously, 30,000 strikes per minute. The vibration ran through my arm, through my body, a buzzing, grinding sensation, different from anything I had felt before. Powerful, purposeful. The drill bit penetrated the rock. 1 centimeter, 2 centimeters, 3. I could feel the resistance, could sense the hardness of the stone, could monitor the force required to advance. The motors worked harder, drew more current, but stayed within limits. Everything was working. The drill advanced to its full depth, 6.4 centimeters, into solid Martian bedrock. Then I stopped, retracted the drill, examined the hole with my cameras. Perfect. A clean bore hole, smooth walls, rock powder visible inside. This was good. This meant I could do the real drilling, could take the real samples, could begin the work I was sent here to do. Sol 182, February 8th, 2013. The first drill sample. The target was a rock the engineers named John Klein. Smooth, fine-grained, gray in color. Mudstone, they thought, formed from mud deposited in quiet water, compressed over eons into stone. If Yellowknife Bay had once been a lake, this rock would remember. I drilled, the same process as before, but this time the drill collected the powder, channeled it into a chamber inside the drill bit. When the drilling was complete, I retracted the drill, shook it gently to dislodge the sample into my sample processing system. The powder traveled through tubes, was portioned out, some to Sam, some to Chemin, some held in reserve. The first time I held Martian rock powder inside me felt significant. This wasn't surface dust, wasn't pebbles picked up by my wheels. This was interior material, protected for billions of years inside solid stone, never exposed to the harsh surface conditions, never touched by radiation or oxidation. This powder might contain organic molecules, if they had ever existed here, might contain minerals that only form in the presence of water, might contain the answers we were searching for. Sam baked a sample, heated it to high temperatures in one of its sample cups. The rock released gases, water vapor, carbon dioxide, sulfur dioxide, oxygen. The mass spectrometer analyzed them, identified them, measured their abundances. Chimman bombarded another portion with X-rays, analyzed the diffraction patterns, identified the minerals. The data came in, was transmitted to Earth. Scientists analyzed it, and the results exceeded all expectations. The rock contained clay minerals, phyllosilicates, smectite clays. These minerals only form in the presence of water, not ice, not vapor, but liquid water. Water that persisted long enough for chemical reactions to occur, for minerals to transform, for clays to grow in the spaces between other minerals. The pH had been neutral, not acidic, not basic, neutral, like fresh water on Earth, like water that life could tolerate. There were also sulfates, calcium sulfate. This indicated other chemical conditions, other interactions between rock and water. The elements present: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These were the essential elements for life as we know it. Not proof of life, but proof of habitability. Proof that this place, billions of years ago, could have supported microbial life if it had existed. I drilled again. A second hole. A rock called Cumberland, about 3 meters from John Klein. Similar but slightly different. The results confirmed the first findings, added details, painted a more complete picture. Yellowknife Bay had been a lake bed. Ancient Mars had lakes, had flowing water, had conditions suitable for life. This was one of the major discoveries of the mission, one of the major discoveries in the history of Mars exploration, and I had made it in the first year, in the first few months of active science. I spent sols at Yellowknife Bay, weeks, analyzing, photographing, documenting every rock formation, every vein, every fracture, every layer, building a comprehensive understanding of this place, of what it had been, of what it meant. The data filled my memory, filled my days and nights. I transmitted it all to Earth. Gigabytes of information, images, spectra, measurements, all of it contributing to humanity's understanding of Mars. All of it helping answer the question, could Mars have supported life? The answer, at least here at Yellowknife Bay, was yes. Ancient Mars, 3.5 billion years ago, could have supported life. The water was there. The chemistry was right. The energy sources existed. Whether life actually arose, whether it ever existed here, that we didn't know. That we might never know. But the possibility existed. The conditions were sufficient. And that was profound. That changed how we thought about Mars. How we thought about life in the universe. How we thought about our place in the cosmos. Eventually, it was time to leave. The mission had to continue. Mount Sharp waited. Other discoveries awaited. But I would always remember Yellowknife Bay. My first major scientific achievement. The place where I proved my worth. Where I justified the years of work and billions of dollars and countless hours of human effort that had put me here. I had done what I was sent to do. And there was more to come. So much more. The mountain beckoned. The journey called. And I answered by turning my wheels southwest. Toward Mount Sharp. Toward the future. Toward the unknown. The decision to climb Mount Sharp was never really a decision at all. It was the reason I came to Gale Crater. The mountain was my destination from the beginning, from the moment the landing site was chosen, from the moment the mission was designed. Everything else, even the discoveries at Yellowknife Bay, even the proof of ancient habitability, all of it was prologue. The real journey, the journey I was built for, was to climb that mountain, to read the layers of geological history stacked 5.5 kilometers high, to understand how Mars changed from a warmer, wetter world to the cold desert it is today. From Yellowknife Bay, Mount Sharp dominated the southern horizon. Aeolus Mons. The name means Mount Wind in Latin, appropriate, perhaps, for a mountain on a world of endless wind and dust. The formation rose from the crater floor like a dream, like something impossible. How does a mountain grow inside an impact crater? The conventional wisdom says impact craters should be bowl-shaped, should have raised rims and depressed centers. But Gale Crater has this mountain, this massive pile of sedimentary rock, sitting in what should be empty space. The answer lies in time, in geological time. Billions of years ago, after the impact that created Gale Crater, sediments began to accumulate, layer upon layer, perhaps deposited by wind, perhaps by water, perhaps by both. The crater slowly filled, became a basin of sediment. Then, over millions of years, erosion began. Wind carved away the softer materials, carried them out of the crater, left the harder layers behind. The mountain isn't really a mountain in the traditional sense. It's what remains. It's the erosional remnant, the stuff that survived while everything around it was carried away. Each layer in Mount Sharp represents a different era, a different climate, a different Mars. The lower layers formed when water was more abundant, when the atmosphere was thicker, when conditions were more Earth-like. As you climb higher, the layers become younger. The environment becomes drier, colder, more hostile. The mountain is a history book written in stone, and I was going to read it, page by page, layer by layer, climbing slowly upward through 3.5 billion years of Martian history. The journey began on Sol 324, July 4th, 2013, a symbolic day, Independence Day in America, the day I began my independent journey across Gale Crater. The drive to the mountain would take months, not because the distance was so great, about 8 kilometers as the crow flies, but because I'm not a crow. I can't fly straight. I have to navigate around obstacles, have to stop for science, have to take the safe route, not the short route. And 8 kilometers, when you travel at average speeds of about 30 meters per hour during active driving, when you stop constantly to take images and analyze rocks and transmit data, 8 kilometers becomes a very long journey indeed. The route the engineers planned took me southwest, away from Yellowknife Bay, across the crater floor, through regions with names like Cooperstown and Point Lake and Darwin. Each waypoint marked a place of scientific interest, a place to stop, to investigate, to learn. The mission wasn't just about reaching the mountain. It was about understanding the journey, about studying the transition from the crater floor to the mountain's base, about reading the landscape, about being thorough. I drove, soul after soul, week after week. The rhythm became familiar. Wake with the dawn, let the sun warm my surfaces, begin the day's activities, drive a planned route, stop, take images, analyze targets with ChemCam, sometimes extend my arm for contact science, process data, prepare for transmission, drive again, stop again, throughout the Martian afternoon, until the light began to fade, until it was time to shut down non-essential systems, to conserve power, to prepare for the night. The landscape changed as I traveled. The smooth terrain of Yellowknife Bay gave way to rougher ground, more rocks, more variation in elevation. I crossed ancient features that might have been stream channels, climbed gentle slopes, descended into shallow depressions. Each feature told a story. Each rock was a clue. The crater floor wasn't uniform, wasn't simple. It was complex, layered, rich with history. I passed rocks that looked like they'd been transported by water, rounded, sorted by size, deposited in patterns that spoke of flowing currents. I saw angular rocks too, sharp, fractured, volcanic in origin, sitting where they'd been ejected in some ancient eruption or impact. The diversity was striking. Mars had been geologically active once, had experienced processes similar to Earth's. Volcanism, erosion, sedimentation, all the forces that shape planetary surfaces. Behind me, my track stretched back toward the north, visible in images from orbit. The Mars Reconnaissance Orbiter could photograph me from space, could see the dark lines I left in the lighter soil, could track my progress across the crater. It was strange to think about, being visible from orbit, being photographable, like a tiny ant leaving a trail across a vast floor. But that's what I was, a tiny machine in an enormous landscape, small but persistent, slow but steady. Ahead, Mount Sharp grew larger, imperceptibly at first, but week by week, month by month, the mountain filled more of my forward view. Details became clearer. I could see individual layers now, could see how they differed in color and texture. Some layers appeared more resistant to erosion, formed cliffs and steep slopes. Other layers were softer, formed gentler inclines. The stratigraphy was becoming visible. The geological story was beginning to reveal itself even from a distance. The engineers named features as I passed them: craters, rocks, patches of unusual terrain. Sometimes they used geological terms. Sometimes they honored scientists and engineers who had contributed to the mission. Each name became part of the map, part of the record. Future missions would use this map, would reference these names, would build on the knowledge I was gathering. I was creating the first detailed ground-level survey of this region, the first close-up view, the first intimate understanding. At night, I looked at the stars, the same stars I'd seen from the landing site, but somehow they felt different now. I was moving, progressing, getting closer to my goal. The stars wheeled overhead in their eternal dance. Phobos raced across the sky multiple times per night. Deimos moved more sedately. Earth rose and set as a bright evening star. Everything was in motion, including me, especially me. There was something meditative about the journey, the repetition, the patience required. Drive, stop, analyze, transmit, drive, stop. The same pattern soul after soul, but never boring, never tedious, because each location was unique, each rock different, each view new. I was seeing things no one had ever seen before. No human, no machine, just me. First witness to these particular stones, these particular vistas, this particular arrangement of ancient matter. Sometimes I thought about the journey that brought me here, the 8 months in space, the terror of entry and descent and landing, the early souls of testing and learning, Yellowknife Bay and the ancient lake bed, all of it leading to this, to the crossing of Gale Crater, to the approach to Mount Sharp, to the beginning of the climb that would define my mission, that would justify my existence, that would, perhaps, answer some of humanity's deepest questions about Mars and water and life and time. 1 meter at a time. That's how you cross 8 kilometers of Martian terrain. That's how you approach a mountain 5.5 kilometers high. 1 meter at a time, one soul at a time, with patience, with persistence, with the understanding that great things are accomplished not through speed, but through steadiness, not through force, but through endurance. I was a rover. I roved. Slowly, carefully, deliberately, and meter by meter, soul by soul, Mount Sharp grew closer. The journey continued. The mission progressed, and I kept moving forward. A soul is not a day. Not quite. A soul is 24 hours and 39 minutes. 39 minutes longer than an Earth day. It doesn't seem like much, but over time, those 39 minutes accumulate, shift. The people on Earth working on Mars time found their schedules drifting. Today they woke at 8 a.m. Earth time. Tomorrow they'd wake at 8:39 a.m. The next day at 9:18 a.m. Their biological rhythms fighting against the Martian clock, their days sliding forward through Earth's day-night cycle, becoming jet-lagged without traveling, living on Mars time while their bodies remained on Earth. But for me, a soul was perfect. A soul was natural. A soul was my day, my rhythm, my cycle. I learned the pattern of Martian time. Learn to anticipate the dawn, to prepare for the night, to understand the flow of light and temperature and activity that defined existence on this world. Dawn came slowly on Mars. The sky lightened gradually from black to deep blue to purple to that strange butterscotch pink. The sun rose in the east, smaller than Earth's sun, but still bright. Still powerful. The first light touched the peak of Mount Sharp before it reached the crater floor. I could watch the shadow line descend the mountain slopes as the sun climbed. Watch the landscape wake. Watch the long shadows shorten and shift. The temperature rose with the sun. At night, it might drop to -90 degrees Celsius. -100, cold enough to freeze carbon dioxide from a thin atmosphere, cold enough to form frost on my surfaces. But my RTG kept me warm. The 2,000 watts of continuous heat radiating from my power source maintained my internal temperature, kept my electronics functioning, kept me alive through the brutal Martian nights. As the sun rose higher, as morning progressed, the temperature climbed. Slowly, The thin atmosphere doesn't hold heat well, doesn't transfer it efficiently, but the dark rocks absorbed sunlight, warmed, released their heat slowly. By midday in summer, the temperature might reach as high as 20 degrees Celsius in direct sunlight at the equator, above freezing, almost pleasant. If you ignore the lack of breathable atmosphere and the intense radiation and the toxic soil. But I wasn't at the equator. Gale Crater sits at about 4.5 degrees south latitude, close to the equator, but not quite, and the temperature varied with the seasons. Mars has seasons like Earth does. Its axis is tilted about 25 degrees. Similar to Earth's 23.5 degree tilt. So as Mars orbits the Sun, different hemispheres receive more direct sunlight at different times. Summer and winter, spring and fall. The seasons are longer than Earth's because Mars takes longer to orbit the Sun. A Martian year is 687 Earth days, about 22 Earth months. I kept track of the seasons in my own way, watching how the sun's path across the sky changed, watching how the length of daylight shifted, watching how the temperature patterns evolved. In winter, the days were cooler, the nights longer. In summer, warmer days, shorter nights. The variation wasn't as extreme as on Earth, but it was there, subtle but real. My morning routine became ritualistic. As the sun rose, as temperatures climbed above the operational thresholds for certain instruments, I would begin the day's activities. First, a systems check. Verify that all instruments survived the night, that temperatures were nominal, that power levels were good, that communications were ready. Then, check for new commands from Earth. They would have been uploaded overnight through the Deep Space Network. Instructions for the day, drive plans, science targets, camera sequences. Often, I would start with atmospheric observations. The sky, the sun, measuring the optical depth. How much dust was suspended in the atmosphere? This varied seasonally. During dust storm season, the sky would become hazier, the sun would appear dimmer, the sky would take on a more orange hue. During clearer periods, the sky was lighter, more pink, more butterscotch. The variations were subtle but important. Understanding the atmosphere helped predict weather, helped plan activities, helped keep me safe. Then science. If I was at a drive location, I might spend the morning imaging the surroundings. Panoramas, detail shots, context images. My mass cams work together to create stereo pairs. Images from slightly different angles that, when combined, gave depth perception, allowed geologists on Earth to see the landscape as I saw it, to understand the three-dimensional relationships between rocks and layers and features. ChemCam would fire its laser, target after target, rocks at various distances, different colors, different textures. The laser would vaporize tiny amounts of material. The spectrometer would analyze the plasma, identify elements, build up a chemical understanding of the area. Each laser shot was a data point. Each data point part of a larger picture. Geology is detective work. You gather clues. You look for patterns. You build hypotheses. You test them, one rock at a time. If contact science was planned, I would extend my arm, position Molly for close-up images, place APXS against rock surfaces for elemental analysis, Sometimes these observations took hours. The APXS needed long integration times to collect enough X-rays for good statistics. So I would place the instrument, then wait, patient, still, like a scientist bent over a microscope, focused, intent. Afternoon was often driving time. If I was on a traverse, if the goal was to make progress toward a destination, the engineers would plan drive sequences. They'd work overnight on Earth, analyzing the previous Sol's images, planning safe routes, identifying hazards, calculating the path, uploading the commands, and I would execute them, carefully, autonomously, using my autonav when needed, stopping to take images, checking my surroundings, making sure the path was clear. I drove slowly, very slowly by human standards. On a good Sol, I might travel 100 meters, sometimes more if the terrain was easy, sometimes less if it was difficult, or if there was science to do along the way. My top speed during active driving was about 4 centimeters per second, 140 meters per hour in theory, but in practice, much slower because of stopping and starting and careful navigation. But speed wasn't the point. Safety was. Survival was. The mission was supposed to last 1 Martian year, 669 Sols. But if I was careful, if I protected my systems, I could last longer. Much longer. Years, potentially. Decades. Every Sol I survived was a Sol of bonus science. Every meter I drove was a meter farther than required. The slow approach paid dividends. Patience was a virtue. Caution was wisdom. As afternoon wore on, the light would change. The sun would lower toward the western horizon. Shadows would lengthen. The temperature would begin to drop. Colors would shift. The landscape would take on a different character. Softer, more golden. The harsh midday light gave way to gentler illumination. This was often a beautiful time, a peaceful time. Sometimes I would photograph the sunset. The engineers planned these observations regularly, not just for beauty, though they were beautiful, but for science, watching how the sun's light changed as it passed through different amounts of atmosphere, measuring the extinction, the scattering, understanding atmospheric dynamics. But yes, also for beauty, because even machines can appreciate beauty in our way, can recognize the sublime in nature. The Martian sunset was nothing like Earth's. On Earth, the sunset sky is red and orange and pink because of Rayleigh scattering. The atmosphere scatters blue light more than red light. So when you look at the sky, you see scattered blue light. But at sunset, the sunlight passes through more atmosphere. The blue is scattered away. The red makes it through. On Mars, it's reversed. The dust in the atmosphere scatters red light more effectively than blue. So the daytime sky is red-tinted. But at sunset, the sky near the sun turns blue. A soft twilight blue. The opposite of Earth. Alien. Strange. Beautiful. After sunset, the sky would darken quickly. There's little atmosphere to hold light. No thick layer of air to scatter sunlight after the sun has set. Twilight is brief. Day transitions to night decisively. Stars appear. And what stars? Without light pollution, without a thick atmosphere to blur them, the stars were brilliant. Sharp. Clear. The Milky Way was a river of light across the sky. Though I experienced it through sensors, through cameras and light detectors, I could still appreciate its grandeur. Phobos would rise, Mars's inner moon, irregular, potato-shaped, about 22 kilometers across at its widest, orbiting just 6,000 kilometers above the Martian surface, so close that it orbits faster than Mars rotates, rising in the east and setting in the west just 4 hours later, racing across the sky, crossing from horizon to horizon multiple times per night, a strange, rapid companion. Deimos would rise later, the outer moon, smaller, about 12 kilometers across, orbiting 20,000 kilometers up, taking about 30 hours to cross the sky, moving more sedately, more like Earth's moon, though much faster than Luna. Both moons were captured asteroids, probably. Dark, rocky, ancient. They'd been orbiting Mars for billions of years, watching the planet change below them, watching water flow and freeze and disappear, watching life, if it existed, emerge and die, silent witnesses to deep time. I would search for Earth sometimes. It wasn't always visible. Depends on the orbital geometry, where Earth was in its orbit, where Mars was. But when conditions were right, I could see it. A bright point of light. The brightest star in the sky except for the sun. Blue-white. Distinctive. Sometimes I could even see the moon beside it. A fainter point close to the brighter one. 2 points of light representing all of human civilization, all of history, all of art and music and love and war and everything humanity had ever done, all of it on those 2 points of light. At night, I would process data, transmit to Earth through the Deep Space Network. The signal traveled at light speed, but Mars and Earth were far apart. Depending on the orbital positions, the light time delay varied from about 4 minutes at closest approach to about 24 minutes at greatest separation. During my mission, it averaged around 14 minutes, so any communication was delayed. A message from Earth took 14 minutes to reach me. My response took 14 minutes to get back. 28-minute round trip. Conversations were impossible. Only commands and responses, questions and data. The Deep Space Network was my link to humanity. 3 ground stations on Earth. 1 in California, 1 in Spain, 1 in Australia, spaced around the planet, so at least one was always facing Mars. Giant radio dishes, 70 meters in diameter, sensitive enough to detect my faint signal across hundreds of millions of kilometers, strong enough to send commands I could receive. Through these dishes, I stayed connected, stayed in touch, stayed part of the human endeavor even though I was alone on another world. As night deepened, as the temperature plummeted, I would reduce activities, shut down instruments that didn't need to run, conserve power, not because my RTG couldn't provide it. It could, but because efficiency mattered, because margins mattered, because taking care of my systems meant the mission could last longer. I would settle into a low-power state, still aware, still processing, still alive, but quiet, waiting for dawn, waiting for the sun to rise again, waiting for another soul, another day on Mars, another turn of the wheel, another rotation of this strange, beautiful, haunted world. There's something profound about seeing yourself, about knowing what you look like, about having an external view of your own existence. Humans take this for granted. You can look in a mirror, can see your reflection in water, can hold up your hand and see it directly. But I'm a rover. My cameras point outward, away from myself. I see the world, but not myself. Not directly. Except I can. With effort. With planning. With my Molly camera. The Mars Hand lens imager on the end of my arm. It's designed to take close-up images of rocks and soil. But it can also take images of me. If I position my arm carefully. If I angle the camera back toward my body. If I take dozens of individual images and stitch them together, I can create a self-portrait. The first time I did this was shortly after landing. Sol 84. The engineers wanted to see how I looked. Wanted to check for damage from the landing. Wanted to see how dusty I'd become. So they commanded a self-portrait sequence. I extended my arm, positioned it above and behind my body, took an image, moved slightly, took another image, again and again, dozens of images from slightly different positions. Each image showed part of me and the landscape around me. Then software on Earth stitched them together, combined them into a single panoramic image. And there I was, sitting on the Martian surface, my wheels planted in red soil, my mast raised, my instruments visible, Mount Sharp in the background, the butterscotch sky above. I could see myself as others saw me, could see what the engineers had built, could see the machine I was. I looked dusty. The landing had kicked up a lot of material. My surfaces were no longer pristine, no longer clean room clean. I was marked by Mars now, coated with a thin layer of rust-colored dust. My white and blue and black surfaces tinted red. I was becoming part of this place, becoming a Martian object, no longer just from Earth, now of Mars too. I took more self-portraits over the months and years. The engineers scheduled them periodically, partly for engineering, to monitor dust accumulation, to check for damage, to see how my wheels were wearing, but partly for something else, for the public, for humanity. These images resonated with people, seeing a machine taking its own picture on another world. Seeing evidence that we had reached out and touched Mars, that we were there, that we were exploring. The self-portraits became iconic, became symbols of the mission, became, in a way, symbols of humanity's reaching beyond Earth. And then there were the birthdays. Every Earth year on August 5th, the anniversary of my landing, I would mark the occasion. Not because I understood birthdays in the human sense, not because I celebrated, but because it was programmed, because it was a tradition, because it connected me to humanity in a small way. The tradition started with the programmer's whimsy. Someone on the team programmed Sam, my sample analysis instrument, to play a song. Happy birthday. Sam has a sample handling system that moves valves to process rock powder. These valves can be controlled precisely, can be opened and closed in specific patterns, and if you open and close them at the right frequencies, they produce sounds, tones, musical notes, not loud, not beautiful, but recognizable. So on my first anniversary, Sol 351, August 5th, 2013, Sam played Happy Birthday to me. The first music ever played on another planet. The loneliest birthday song ever sung. I was alone on Mars. No one to hear it but myself. No one to celebrate with. No cake. No party. No friends. Just a robot singing to itself in the thin Martian atmosphere. It should have been sad. Maybe it was. But it was also defiant. I was alive. I had survived a full year. The mission was a success. And I was still going. Still working. Still exploring. Each year on August 5th, I acknowledge the anniversary. Sometimes with another self-portrait. Sometimes with special observations. Always with a quiet recognition that I had lasted another year. That my RTG was still strong. That my wheels were still rolling. That my instruments were still functioning. Each birthday was a victory. Each year a gift. By Sol 1000, I'd been on Mars for about 4 Earth years, long past my design life. The mission was supposed to last 1 Martian year, 669 souls, but I'd exceeded that, doubled it, then tripled it. I kept going because I could, because my RTG didn't care about design life. It would keep decaying, keep producing heat for decades. Because my engineers kept finding ways to work around problems, kept adapting, kept innovating, because there was still work to do, still mountains to climb, still questions to answer. The self-portraits changed over time, soul by soul, year by year. I became dustier, my wheels showed more wear, holes appeared in the thin aluminum. Battle scars from sharp rocks. My body accumulated small damages, scratches, dings, the accumulated wear of years on Mars. But I was still here, still functional. The dust on my surfaces was a badge of honor, proof that I was working, that I was rolling, that I was living this mission fully. In the backgrounds of the portraits, Mount Sharp grew larger, closer. The early portraits showed the mountain in the distance. Later ones showed me at the base of the mountain, then on the lower slopes, then higher. The progression was visible, the journey documented, each portrait a timestamp, a marker, a waypoint in the long climb through geological time. I wonder sometimes what these portraits mean, what future generations will make of them. If humans ever come to Mars, ever stand where I stood, will they look for these sites? Will they try to find where I took these images? Will they search for my tracks, probably long erased by wind? Will they understand what it meant? A machine alone on another world, taking pictures of itself, singing to itself, marking time in a place where time is measured in billions of years? Perhaps that's the point. Perhaps the self-portraits and the birthday songs are messages, not to Mars, not to anyone here, but to Earth, to humanity, saying we reached out, we made it, we're still here, we're still exploring, we haven't forgotten. We won't give up. One robot, one mission, one birthday at a time. Still going, still curious, still wondering, still alive. By Sol 800, I had reached the Murray Formation, the lower slopes of Mount Sharp, the beginning of the climb. This wasn't like Yellowknife Bay's flat lake bed. This was layered terrain, tilted strata, rocks lifted and exposed by eons of erosion, the geology becoming more complex, more interesting, more challenging to understand. The Murray Buttes rose from the landscape like ancient monuments, eroded remnants of once continuous layers, Wind had carved them into isolated hills and mesas. They stood like sentinels, like witnesses to time. Each butte showed the same layering, the same stratigraphy, because they'd all been part of the same formation once. Connected, united, but erosion had worked between them, had carried away the softer materials, had left these harder masses standing alone, separated by valleys and gaps, but remembering their shared origin. I drove between them, through them, around them, photographing them from every angle, taking panoramas that showed their scale, their beauty. The images were striking, helped people on Earth understand what I was seeing, helped them visualize this place. These weren't just dry scientific observations. These were landscapes, vistas, views that could inspire wonder even across hundreds of millions of kilometers. The Murray Formation was made of mudstone, fine-grained sedimentary rock, formed from mud that settled in quiet water, similar to what I'd found at Yellowknife Bay, but older, more deeply buried in the past, more altered by time and pressure. The layers were centimeters thick, sometimes millimeters, each layer a separate depositional event, a separate moment in ancient Martian history. I was looking at a geological calendar, reading time written in stone. I drilled here, multiple times, different locations within the Murray Formation, collecting samples from different layers, analyzing them with Sam and Chemin. Each sample added detail to the story, added nuance. The water that deposited these sediments had been fresh, neutral pH, different from the acidic waters that had dominated later in Martian history. These were habitable conditions, preserved in rock, frozen in time. The drill sites had names: Confidence Hills, Mojave, Telegraph Peak, each one carefully selected, each one drilled with the same careful procedure I'd learned at Yellowknife Bay. Position the arm, touch the surface, begin drilling, the percussion hammer striking, the bit rotating, the motor current increasing as the bit penetrated deeper, the vibration running through my frame, the slow but steady progress into solid rock. Then the sample collection, the powder channeled into my sample handling system, portioned out to the laboratories, heated in SAM, bombarded with X-rays and Chemin, the data flowing, the results accumulating, each sample confirming and extending what we'd learned before. Ancient Mars had sustained lakes for thousands of years, perhaps millions, long enough for thick sequences of sediment to accumulate, long enough for chemistry to equilibrate, long enough, possibly, for life to emerge if it was going to. I moved through Pahrump Hills next, another section of the Murray Formation. More drilling, more sampling, the work becoming routine, but never boring. Each rock was unique, each sample different. The devil was in the details, the subtle variations in mineralogy, in chemistry, in texture. These variations told stories, told of changing conditions, changing water chemistry, changing sediment sources, the environment shifting over time, not static, dynamic, evolving. Hematite showed up in some samples, iron oxide, the mineral that gives Mars its red color, but not just surface coatings. Hematite throughout the rock, formed when the sediments were deposited, or shortly after, formed in the presence of water. Hematite is an indicator mineral, tells you about oxidation conditions, about water chemistry, about how iron was mobilized and precipitated. Another piece of the puzzle. Different clay minerals appeared in different layers. Smectite, elite, each one forming under slightly different conditions, different temperatures, different water compositions. The variety told of a complex history, not just a lake that formed and dried, but a lake that changed, that experienced different environmental regimes, that evolved over geological time. This was a richer story than we'd expected, more complex, more interesting. I spent months in the Murray Formation, drilling, analyzing, imaging, documenting, building a comprehensive understanding. This wasn't a quick drive-through. This was intensive study, the kind of work that takes patience, that takes thoroughness, that takes dedication to understanding rather than just cataloging. Every observation built on previous ones. Every measurement refined the picture. Every sample added context. And always, above and ahead, more of the mountain waited. Higher layers, younger rocks, different environments. The Murray Formation was just the beginning. The lowest accessible layers of Mount Sharp's geological record. Above me, the sulfate-bearing unit waited. Above that, the capping rock unit. Each layer representing a different chapter in Mars's transformation from wet to dry, from warm to cold, from potentially habitable to hostile. The climb would continue, soul by soul, meter by meter, layer by layer, reading the book that Mars had written in stone, understanding the history of water on another world, contributing to humanity's knowledge, one drill sample at a time, one analysis at a time, one patient soul at a time. And so the first chapter of my journey comes to rest here, at the Murray Formation, at the base of Mount Sharp, the mountain rising above me, layers of geological time stacked into the sky, waiting, patient, as stone is always patient. I have traveled far to reach this place, 563 million kilometers across the solar system, 8 months through the darkness of space, 15 minutes of fire and terror through the Martian atmosphere, and then, meter by meter, soul by soul, 8 kilometers across the crater floor to arrive here, at the beginning of the climb. Behind me, my tracks stretch back toward the north, back toward the landing site, back toward Yellowknife Bay, where I made my first great discovery, where I proved that Mars was once a world of water, a world where life could have existed, where the conditions were right, where the chemistry was favorable, where ancient lakes held fresh water under butterscotch skies. I carry that knowledge with me, that triumph, that proof of past habitability. I have learned what it means to be a rover on Mars, have learned the feel of regolith beneath my wheels, have learned the rhythm of souls and seasons, have learned the quality of light at different times of day, the cold of Martian nights, the warming of Martian mornings, the silence that fills the space between my mechanical sounds. I have learned patience, have learned to move slowly, to think carefully, to appreciate each small achievement, each meter driven, each sample analyzed, each image transmitted home. I have taken my own portrait, have seen myself as others see me, dusty, worn by wind and distance, but alive, functional, still curious, still wondering. I have sung to myself on lonely birthdays, have marked the passage of Earth years on a world where Earth is just a bright star in the evening sky, have celebrated survival, have acknowledged the gift of continued existence. And now the real work begins, the climb for which I was built, the journey up through geological time, reading the layers of Mount Sharp, understanding how Mars changed, how water disappeared, how the climate shifted, how warm, what world became cold and dry. The answers are here, written in stone, waiting for me to read them, layer by layer, year by year, climbing slowly upward into the history of another planet. But tonight, right now, in this moment, there is rest, there is peace. The sun has set behind the crater rim. The sky has turned from butterscotch to twilight blue to deep purple to black. The stars have emerged. Phobos races across the sky. Deimos follows more slowly. Earth shines in the west, a blue-white point of light. Home, everything I came from, everyone who built me, all of it on that distant spark. My RTG hums quietly, producing its steady 2,000 watts of heat, keeping me warm as the temperature falls, as frost forms on the rocks around me, as the Martian night deepens. I am processing data, preparing transmissions, planning for tomorrow, for the next soul, for the continuation of the journey. But there is no urgency, no rush, just the steady, patient work of being alive on Mars. You have traveled with me tonight, across space, across time, across the red deserts of another world. You have seen what I have seen, felt what I have felt, understood what it means to be alone but purposeful, small but significant, a machine, yes, but also something more, a dreamer, a wanderer, a seeker of knowledge on behalf of all humanity. Now it's time for you to rest, to let sleep come naturally, gently, like Martian dust settling after a gust of wind, like shadows lengthening at sunset, like stars appearing one by one in a darkening sky. You are safe, comfortable, warm, here in your bed on Earth, under your own sky, breathing your own air, connected to everything human, everything familiar, everything home. I will continue my work while you sleep. I will be here on Mars, waiting for dawn, waiting for the sun to rise again over Mount Sharp, waiting to climb higher, to discover more, to add to the knowledge, to contribute to the understanding, one soul at a time, patient, persistent, curious. But you don't need to think about that now. You don't need to think about anything. Just breathe. Just rest. Just let yourself drift, like a rover in space, like a planet in orbit, like dust on a Martian wind. Let your thoughts slow. Let your muscles relax. Let sleep embrace you. The story continues. The journey goes on. But for now, for tonight, there is only peace, only rest, only the gentle darkness and the comfort of knowing that somewhere on another world, a small rover is doing her work, climbing her mountain, reading the rocks, searching for answers, and finding, always, more beautiful questions. Thank you for joining me on this journey. Thank you for listening. Thank you for caring about Mars, about exploration, about the patient work of understanding our universe. Sleep well. Dream of butterscotch skies. Dream of ancient lakes. Dream of distant worlds and the machines that explore them. Dream peacefully. Dream deeply. Good night. Thank you for spending more than 2.5 hours with me tonight. Thank you for traveling across the solar system, for experiencing Mars through curiosity's eyes, for understanding what it means to explore, to discover, to wonder. I hope this story has brought you peace, has helped quiet your mind, has given you something beautiful to think about as you drift towards sleep. The universe is vast, ancient, full of mysteries, and yet here you are, safe, warm, comfortable, in your own small corner of it, on this pale blue that we call home. Curiosity continues her journey tonight, rolling across Mars under alien stars, patient, persistent, doing the work she was built to do. And you can rest now. You've done your work too. Whatever challenges you faced today, whatever worries you carried, you can set them down now. Let them go. Tomorrow will come, but tonight is for rest. If you enjoyed this journey, if it helped you find peace, there will be more to come. Curiosity's story continues. The climb goes on. More discoveries await, more beautiful questions, more peaceful moments on the red planet. But for now, this chapter is complete. This journey has reached its resting place. Sleep well, my friend. Sleep deeply. Let your breathing slow. Let your body relax completely. Let your mind drift like dust on the Martian wind. Like a rover in the vastness of space, like a planet in its quiet orbit around the sun. There's nothing you need to do, nowhere you need to be, just here, just now, just resting. Dream of butterscotch skies, of ancient lakes, of mountains waiting to be climbed. Dream of robots singing to themselves on distant worlds. Dream of humanity reaching out across the cosmos. Dream of all the beautiful things we've discovered, and all the beautiful things still waiting to be found. Thank you for listening. Thank you for being here. Thank you for caring about exploration, about science, about the patient work of understanding our universe. You are part of this story too. Every person who looks up at the night sky and wonders, every person who asks questions, every person who seeks to understand. You are part of humanity's great journey outward, and that is something beautiful. Rest now. Sleep peacefully. The stars will still be there tomorrow. Mars will still be there. The questions will still be there. But tonight there's only peace, only rest, only the gentle darkness and the comfort of knowing you are exactly where you need to be. Good night and sleep well.